Hi, this is Tim, and today we are here to bring this old beauty back to life. Oh man. Today we're going to talk about how you can wire three-phase industrial equipment when you don't have three-phase power. And this is a question I get a lot, especially guys in their home shops or just in areas where three-phase isn't available, is they buy, a milling machine, a lathe, or an air compressor or something, and it's three-phase, and like, hey, how can I get this to run? So there's several different ways that you can power a three-phase piece of equipment. Obviously, the easiest way is to get three-phase to your location. Now, if you're at a home or you're in an area that three-phase isn't available, then obviously this isn't an option. So after that, you could swap out the motor on the machine for a single-phase motor. But in a lot of cases, that's not an option, or, especially in your bigger horsepowers, it may not be a single-phase option available. So then, you can either use an AC drive or a phase converter. Now, I have a phase converter back at my shop, so I'm going to show you that there. But today I'm here to wire an old shaper up, and it has a three-phase motor on it. So we're going to use an AC drive to power the shaper. So a little bit about AC drives. You'll want to look on the side of them, and they will tell you whether they can be ran off a single phase. So this is an Automation Direct GS2. I've used a lot of these. They're really good for powering three-phase equipment up to 2 horsepower. And all you need is 220 single phase. And actually some of their smaller ones, like the ones that we fit on our trainers, will run off 120. So you have just plug it into the wall. But this one right here is 2 horsepower, and it can run off a single or three-phase. And depending on whether you're running single or three-phase will determine how many amps it pulls. So if we were running three-phase power, then this drive would pull 2.7 amps. But since we're running off a single phase, and it's having to consume more power on those 2 legs, then it's going to require 7 amps. So make sure you check the nameplate data, make sure it can run on single phase and how many amps it needs for single phase, because it will be more amps on single phase. Now, another question I get a lot is, I've got an old machine with an ancient motor. Will it hurt it to run off a drive? Well, I'm not a motor specialist, so my true answer is, I don't know. But this old Bridgeport right here has been running for years off of a drive, and it's never had any trouble. Then we have this old South Bend right here that has also been running on an AC drive. And you can see in there, that's a pretty old motor right there, and it's never had any trouble either. Now, the one caution I will give about that is both of these machines are set to coast to stop. So they don't use deceleration or any type of DC braking features, and those could heat up the windings more. But really, if you have a concern about that, probably need to talk to the drive manufacturer. So here's this old shaper that we're going to be wiring up today, and of course, the first question you're going to ask is, why in the world are you wiring up a shaper? There's a mill sitting over there, there's a lathe sitting over there, and here's this 100-year-old shaper. Well, because this is just a peer back into history, back into the Industrial Revolution. I mean, it is just so classic. So really, it has no purpose except to watch this old machine run. So we are going to do this one a little bit different. We're actually going to try to find an old box to conceal the drive in. So right now we're going to mount it on the wall and just make sure it runs, make sure it has no major issue before we go down that route. But the first thing you're going to want to do is you're going to want to know, especially on an old machine like this, is what's the voltage. So these could be 480, they could be 220, they may have came from overseas where they could be 380. And some of the odder ones, they could be 600 volt. So you want to make sure that voltage. In the case of this one, it does have a nameplate on the back of the motor. So we'll go around and have a look at it. And right here is the nameplate of this motor. There you go. I'm not sure what that says. I think that's a frame size. Right there, that definitely says 220 volt. And yeah, boy, that is just one beefy 2 horsepower motor. So on this one, our motor can only run 220 volts. That makes it really easy. But let's say you had a motor that had no nameplate, or like so many motors, they can run off a combination of either 480 or 220, and you didn't have anything to identify. The next best thing to look at is going to be your motor starter box. This has a start-stop, and it's across the line, so there is no transformer. It's going off the main power. So if we open this up, First, just look at this. Everything about this is just so well made. I mean, they just really, this is just a beautiful motor starter panel. And we're going to be looking right here. This is the coil. And hopefully, there it goes. Does that say 220? No, it doesn't. So that says 22D, 2G. So it doesn't actually say that it's 220 here. So in this case, you would want to look in here and figure out, hopefully it would say somewhere on here. All right, if you look long enough, it says right there, this is a 208 or 220 motor starter. So at that point, we would be sure that we need to feed this 220 volt. Now this thing is just so pretty. I may just take this back and hang it on the wall. So I'm not going to butcher it. I'm actually going to add another junction and everything later, especially after we're sure that the shaper runs well. All right, so next we're going to need to look at this a little closer and figure out what all these wires are in this. All right, and here was the incoming power, so we know wherever these three wires go. All right, there's our incoming, so 1, 2, 3. Then we have a wire kind of coming around here to the side, and another wire coming around here to the side. All right, and that's going to there. So this is going to be a motor lead, and this is going to be a motor lead. I'm not really seeing where that third motor lead comes around. It comes around the back through a heating element. These old motor starters, they used heating elements to kick them out if they were pulling too many amps. So this is definitely one motor lead, that's another motor lead, and the third one comes through here, through that heating element. So now that we know which one is our three motor wires, we know the other ones come to the start-stop button. And what we're going to do is we're going to keep this as it is, but we're going to wire the start-stop to the start-stop on our drive. Here's the drive, and right here it says line, and that is where our incoming power is going to come in. If we look in the bottom, it says motor, and then you could also have a brake. We're not going to use the brake. But it has L1, L2, and L3, but if we look further in the manual, we're going to be using L1 and L2. And please hook up the ground. Now, just so we make sure we understand, this is going to be 220, which is 2 legs of 110, just like your oven or your hot water heater or any 220 volt household device uses. All right, so when you're finished, yours should look like this. So we have our L1, we have the black wire, L2, we have the white wire, and then we have this ground hooked up. And we're going to go ahead and wire our motor in and our start-stop, and then we'll go wire the power to this. All right, we've identified which ones are the motor leads, so I'm going to take them loose first. There, and there. And we want to make sure that we don't get them confused with these start-stop. And the big reason for that is we're going to have 220 on our motor, but the control circuit on this is only 24 volts. So if you get these wires swapped, you're going to burn the drive up. All right, so I've got the three motor leads out of the way, which leaves us with 3 more wires. There's a wiring diagram right here that tells us which wire is going where. So this wire is going to be going to our start contact, this wire is going to our stop contact, and this wire is going to be common off of the 2 of them. All right, so I know this will shock everybody who actually knows me, but now we are going to read the manual. Mainly because right here on page 423, actually say 422 through around 28, they have all different types of examples of ways to wire this depending on what you want to do. So they have a run and a stop. Now ours is going to be start and stop, but this is the circuit we're wanting right here. It tells us the parameters that we're going to need. Also, Automation Direct, there's a line missing right there. For, you know, people who are trying to do this, they kind of look at it and they're like, how do you get the DCM over? But there should be a wire right there coming across. So we're going to wire the DCM to our stop. And then we're going to come out of our stop and we're going to come to our start. And we're going to bring a wire across to DI2. And off the other side of our start, we're going to go to DI1. And we're not going to have our forward and reverse on this because this is mechanically reversed. Okay, so I went ahead and retraced all the wires just to be sure. And so these 3 right here are going to my motor. So we're going to hook them up right down here, T1, T2, and T3. All right, then I traced these wires back. And so this one goes to both the start and the stop. And that one is supposed to go to DI3. And this one is our start button, so it goes to DI1. And finally, this one goes to the other side of our stop button. So it goes to DCM. And if you're looking at your manual right now, scratching your head, it's because there's a line missing in the manual. So right here, there should be a line across here, bringing that DCM over to that stop contact. And that is it. So these are your 3 control wires. They're going to our start stop, and these are our 3 motor wires. All right, so as I alluded to earlier, I forgot to hook the ground up on this. The reason is, one, we were just temporarily wiring this to see if it operates, but that was really a bad idea, because if you're going to run a machine at all, it needs a ground. Now, with this machine, it originally didn't have a ground. So I'm going to go through exactly how you should hook a ground to it. So on the drive side, it's really easy. Right here, this one has a green screw, and that is where the motor ground is supposed to connect. It was originally designed to have this conduit as the ground, but like so many machines, you can see here, it's been jerked loose, and we're going to fix all this in the end. But even during this test period, we need to get a ground from this screw to this motor. Okay, so this one is definitely different than what you would see on a motor today. But what I'm going to try to do is take this stud loose and see if I can put a ground ring behind it. So one thing I noticed is this is actually phenolic that this is running through. So I want to make sure that this stud right here has continuity to the motor case, and it does. So now we put a terminal behind this stud, and we're going to tighten it down. Then we're going to run it back up through this conduit. All right, I've ran the wire through there, and I went ahead and put a ring terminal. And we're going to hook it on right here. But we also went ahead and made a bracket here to hold this in place, at least until we figure out how we're going to mount this permanently. All right, we got this secured a little better. Again, this is all temporary, but I think that'll keep us from jerking any wires out. And we've got our ground hooked up now. So now we're going to need to pop open our control panel and get these wired in. So here's your typical household, garage, or shop panel. And you see we have 2 big wires here, and they're going to be 120 on each leg. And then between them, we'll have 220. And then usually you'll have a white wire, such as this one here. That's going to be our neutral, and then you'll have a copper-looking wire, and that's going to be our ground. A couple things. The drive doesn't require our neutral wire, so we don't need to hook to it. What we do need to hook to is the ground. So I have a breaker installed right here. It's a 20 amp double pole breaker. So it's going to pull 120 off of this leg and 120 off of this leg. And together you're going to get 220 out of here. And then our ground will go right behind it here. All right, so we have it all wired up. Just take 5 minutes and check over your circuit again. Make sure the 3 wires that you have connected to your motor are going to T1, T2, and T3. And mainly that these control buttons right here are completely separated, and they're going to the DCM terminal, the DI1 terminal, and the DI3 terminal. All right, fire in the hole. Well, that's never good when you power one up and it says error. So let's look in the manual together. Oh, okay. So yeah, we do have EF. Okay, it's coming back to me. When you wire these for start, stop, that terminal is not used by default for what we're looking for. So if we go look at our manual here, P301, setting 2. You hit the program button and hit it till it comes around to 3, and then you go to up to get to 301. And now we're going to take that to 2. All right, so now the EF fault has gone away. I think we're ready to go, but the next challenge with this, well, and with a lot of machines that are designed to run only one direction, is I don't know which direction is supposed to rotate. So I'm going to spend a few minutes trying to figure out an arrow, and then maybe I'll just look at the linkage. But I'll put a link to a video in the description that explains where you hook the 3 wires to your motor determines its rotation. And if your rotation's backwards, you'll swap 2 of the wires. So next we want to bump the motor and see if we're going the right direction. The issue is, I don't know which direction that is. I forgot one other setting that I had set on the mill and the lathe, and that's the coast to stop feature. And especially with this machine, if it does bind up or something when we're starting it, I think we definitely want that on. And that's going to be right here, P1.00. Coast to stop is, we want to set it to 1. So we're going to hit program, hit it again to get to 1.0. Now right past that is the acceleration time, which defaults 10. It's probably okay for this machine. Alright, and my wild guess is that this motor needs to rotate clockwise. Uh-oh, we didn't get anything. Okay, I took it all apart just to realize that I forgot to set the source of operation. Right now it's still on keypad, and it needs to be on external control, and we're going to make the keypad stop disabled, so it needs to be on 2. Okay, see how lucky we get. Okay, if my guess was correct and this thing's supposed to be going clockwise, then I have the motor backwards. So we're going to need to swap the wires. To do that, you'll definitely want to kill the power. All right, so now that our power is off, we're going to want to swap 2 wires. And you want to do this on the motor side. So if this was a 3-phase drive, if you swap 2 of the top wires, it would not make a difference in the direction. All right, let's try it again. Oh, let's turn the power back on. Hope this video has been helpful. In the next video, we'll go through how the phase converter works at our shop so you can see both options for making 3-phase power. This thing is just beautiful. Now this is the world's smallest shaper probably. In fact, here's a picture of my dad beside of a shaper. This is the only shaper I ever knew. But I mean, this is just such a work of art and really tells the history of where we came from machining wise. Till next time.
All right.
Oh yeah.
Hi, this is Tim.
And this is Amber of TW Controls.
We run the automation store.
Be sure to subscribe for more great videos.
And like this video and comment on what you would like to see next.
Visit our website where we offer a full line of PLCs, simulators, control panels, PLC trainers, and more.